Okay, we're going to look at another way that you can solve square roots. We call this by solving square roots by taking the square root, or the square root property. Okay. Notice if we look here at x squared equals 25, there are two numbers that I can use to make this positive, or to make this true rather. So if I use negative 5 squared, that's 25, but if I use 5 squared, that's also 25. So the other way that we can look at this is that we want to undo a squared. So the way that we undo a squared is with a square root. So if I were to square root this, the square root of 25 is, we break that down, this is 5 and 5. 5's come out, no one's left at home, so we just get 5. Right? And here we had x squared square rooted. These are x times x, so a pair of x's still come out, so we have x equals 5. But notice that only gives us 5, it doesn't give us the negative 5. So anytime that you take a square root, you have to do a plus or a minus to represent both of our answers. Right? So we're going to have plus or minus 5. Okay? So right here, this is when you take the square root of both sides of an equation, you must always write plus or minus. Okay? So what you want to do, you want to isolate what's ever being squared. So you want to do this. You're going to do the order of operations backwards. You undo any adding or subtracting first, and then you undo any multiplying, right? Because remember, you have PEMDAS. You do add, subtract. When you're solving, you undo, add, subtract first, then multiply and divide. Okay? And then you're going to take the square root of both sides, right? This will have two equations because we got the plus or the minus. So then you finish solving for the variable if you need to. So if we look at our first one, we have x squared equals 4. So the other day when we did this one, we looked at subtracting the 4 over to the other side, and then we factored. And this was a difference of squares, so we took the square root of this one, which is x, the square root of this one, which is 2. We took a plus and a minus. And then we set each of those equal to 0, which gave us x is 2 and negative 2. Right? So since this doesn't have a linear x term, right? Remember our other equations from the other day where we had like x squared plus 4x plus 5? Right? This is our linear x term. Since there's none of that here, we can get the thing that's squared by itself and then take the square root. So this thing squared is already by itself, so I'm going to undo squaring it by taking the square root. Again, when we take the square root, you have to put plus or minus, and you only need to put the plus or minus on the side with the number. Okay, so we're going to have x equals, if we break down 4, it's 2 and 2, so there's a pair of 2's that go out on a date, and then we have our plus or minus from the outside. Okay, so notice we could do this by factoring a difference of squares, or we could do it with the square root property and get the same answer. Okay. If we look at b, b's a little bit different because notice 18 is not a perfect square. So when I take the square root of both sides, because this is already alone, remember we need plus or minus, so I have x equals, if I break down 18, I'm going to break it down sideways instead of going down. So we have 9 and 2, and 9 is 3 and 3. So I have a pair of 3's and then a loner 2. So the 3 comes out, and then the 2 stays at home, and then we have our plus or minus. Well, that was not anywhere close to what I wanted. Plus or minus 3 root 2. That's what I wanted to write. Okay? So this becomes our answer that we have here. Notice if we had tried to subtract and factor, there's nothing that multiplies to 18 and adds to 0. So this is a way that we can come up with an answer for things that are not factorable. If we look at this one, we have an expression inside the quantity squared. So I want this part alone, which notice it is. There's nothing being multiplied out front here, and there's nothing being added or subtracted here. So I want to undo squaring it first by square rooting both sides. When you square root, you need plus or minus. So I have the plus or minus out in front of the 25, or root 25. When you square root a squared, these undo each other, and you're left with just the x minus 3. So that equals, again, if we break down 25, that's 5 and 5. Those are a pair. They go out of the root. Notice we still have our plus or minus. Right, so we have plus or minus 5. So it may help you to write x minus 3 equals 5 and x minus 3 equals negative 5. Okay? We have one where it's positive and one where it's negative. So now we can solve these two equations. So I'm going to add 3 here. So we have x is 8. And I'm going to add 3 here. So negative 5 plus 3 is negative 2. And then these two are our answers. Okay? Let's skip to this bottom one, okay, on E. So this one, there's nothing inside, but I do have something being added on the, or subtracted on the outside. So I want to undo that first. So we undo subtracting by adding. So we're going to have x squared equals 21. So notice there's still no linear x term, right? This one right up here, there's no x to the first. So I can just take the square root of both sides. So if I take the square root, remember you have to put plus or minus. So x equals, remember squared and square root undo each other, so we're left with just the x. 21 is 7 and 3. Notice neither of those can break down more, and they're not a pair, so neither one of those can come out. So we just keep it as plus or minus root 21. Okay. Now, if we look at f, notice this is set equal to 0, just like we had the other day when we were doing these ones, but this one is not a difference of squares, it's a sum of squares, right? So we can't factor that one. So since there's no linear x term, right, we're going to move the 36 to the other side. So we're going to have x squared equals negative 36. Well, I want the squared to be gone, so I'm going to square root both sides. Remember, we put plus or minus. Well, remember that this is really the square root of 36 times the square root of negative 1. And remember that the square root of negative 1 is really I. And we still have our plus or minus that we have out here. So this will turn into the square root of 36. Well, that's 6 times 6, so the pair of 6's can come out on a date. And then we have the I, because the square root of negative 1 is I. So it'll be plus or minus 6i. And then over here, squared and square root undo each other, so we're left with just x equals plus or minus 6i. Okay. If we flip to the back, not to the back, to the next page. Just joking. The next page. Here we go. Page 7. If we look at this one on H, notice we want to undo multiplying. So we undo multiplying by dividing by negative 2. So we have x minus 3 squared equals negative 25, because 50 divided by negative 2 is negative 25. Well, notice there's nothing else outside of the quantity squared. I don't have anything being multiplied here. I don't have anything else being added or subtracted. So now I'm just going to undo the squared. Well, to undo squared, you take the square root. When you take the square root, you have to take plus or minus. Remember, the squared and the square root undo each other, so we're left with x minus 3 on the left side. Here, if we take 25, well, let's go with this. This is plus or minus the square root of 25 times the square root of negative 1. So hopefully you remember by now that the square root of 25 is just 5. So this is plus or minus 5, or you can break it down and say that 25 is 5 times 5, and then the pair goes out on a date. Right? And then remember that the square root of negative 1 is I. So this part here turns into I. So this will be plus or minus 5i. Okay? So here, the x is not by itself, so we're going to set up two equations. So I'm going to move over to this side right here. So we're going to have x minus 3 equals positive 5i, and x minus 3 equals negative 5i. Well, I want the x by itself, so we have subtract 3 on both of these. So I want to undo subtracting 3. So I'm going to add 3 and add 3. Well, this is a number and this is an imaginary number, so these cannot be added together. So I'm just going to write x equals 3 plus 5i. And that will be one of my answers. And then same thing here. This is a real number. This is an imaginary number. You cannot add the two of them together, so they just go next to each other. So 3 minus 5i. You can, if you would like, write this as one answer with a plus or minus in between. So notice the 3 has the same signs, and then the 5 has the plus or minus. So you could choose to write this as x equals 3 plus or minus 5i. And that would be your answer. Let's look at K. So here, notice we have two things outside of the root. I have the 16 outside of the root and the negative 2 outside of the root. We're going to undo the order of operations backwards. So we're going to undo add subtract first. So we're going to undo adding 16. So we're going to subtract 16. We have negative 2 times x plus 7 squared equals negative 6. Okay. This is being multiplied. Please be careful. This is not subtracting 2. You're looking at what it's doing to the quantity squared. So it's multiplying, not subtracting. So we're going to undo multiplying by dividing by negative 2. we have x plus 7 squared equals positive 3. Let's make that. So I want to undo squaring it, so we're going to square root both sides. Remember, when you square root, you need a plus or a minus. So now we have x plus 7 equals plus or minus root 3. Again, we're going to set up two equations. I'm going to have x plus 7 equals positive root 3, and x plus 7 equals negative root 3. So I'm going to undo add 7 by subtracting 7 on both of these. So here, this is a root, this is a number. Remember, you can't add numbers and roots, so you just write it as negative 7 plus root 3. And then this one would be negative 7 minus root 3. Again, you can combine it to one answer. Notice both the 7s are negative. This is a minus, this is a positive, so you could write it as x equals negative 7 plus or minus root 3. And that's how you solve using the square root property.